Hello students, welcome back to OrganiChemVerse. In the last lecture, we have seen what is organic chemistry and what are the applications of organic molecules. In this video, we are going to learn why carbon is considered as the king of organic chemistry. Students, just think, why is it that out of 118 elements on the periodic table, the entire branch of chemistry is dedicated to just one element, that is carbon? The answer lies in the incredible versatility of carbon. So, get ready to find out why this simple, abundant element is the undisputed king of organic chemistry. The reasons why carbon is the king of organic chemistry are the position of the carbon in the periodic table, the tetravalency of carbon, catenation, hybridization, isomerism, and bond stability. Some of you might not know the terms we have used here, but don't worry, I'm going to explain them one by one. At first, let's understand what is the position of carbon in the periodic table. The carbon with atomic number 6 is positioned in the second period of the periodic table between electronegative elements like nitrogen, oxygen, fluorine, and electropositive elements like lithium, beryllium, boron. You can see that it is placed in between electronegative elements and electropositive elements. Because it has an intermediate electronegativity which allows it to form stable covalent bonds by sharing electrons rather than losing or gaining electrons. Because of the same nature, the carbon will also interact with the hydrogen and form many organic compounds like hydrocarbons. And all this because of its position in the periodic table where it is having intermediate electronegativity. Next, tetravalency. What do you mean by tetravalency? It is the capacity of carbon to form bonds. Carbon can form 4 bonds. How do we know that? By writing the electronic configuration. The atomic number of carbon is 6 and its electronic configuration is 1s2, 2s2, 2p2. In the valence shell, you can see that there are 4 electrons. It's not easy to give up 4 electrons or take 4 electrons. Rather, it tries to share the electrons. Because it is sharing the electrons, it is going to form covalent bonds. And since it is forming 4 covalent bonds, the probability of forming different compounds will be higher and higher. What does that mean? Say with only 2 elements, say hydrogen and chlorine, it can form many compounds. You can take either all hydrogen or chlorine or hydrogen and chlorine combination. Like this, we can form many more compounds, and this is possible due to 4 valency of carbon. Now let's understand what is catenation. Let's discuss what is catenation. Catenation is the ability of carbon atom to form strong covalent bonds with the other carbon atoms, allowing them to link together to form long chains, branch chain, rings, and complex structures. Long chains or straight chain of molecules can be observed in biomolecules like fatty acids, where you see the carbons are linked in a straight chain like this. We have branch chains where different carbon chains are linked together or where there is a branching like this, right? This can be observed in protein molecules. They can be even ring or cyclic structure. Like they can have 3-membered rings, they can have 4-membered rings, they can be 5, 6, and the list goes on. And they can have combination of all of them to form the complex structures. Like in case of complex proteins, DNA, RNA, etc. This unique property is fundamental to organic chemistry, and that's why there is such a vast number of carbon-based compounds in the nature. Carbon's small size and high energy of the carbon-carbon bond are the key reasons for its exceptional catenation ability. Now let's understand what is hybridization. Hybridization is property of the central atom which undergoes intermixing of atomic orbitals to form different hybridization. It can be sp3 hybridization, sp2 hybridization, or sp hybridization. Carbon forms different compounds through different hybridization. What does that mean? Whenever all the carbons are sp3 hybridized, we call the compounds as alkanes. If the compounds have sp2 hybridized carbons in them, we call them as alkenes. And if they have sp, then we call them as alkynes. Because it forms different hybridization, each compound will have different types of bonds. What does that mean? The alkanes will have the single bonds in them, alkenes will have double bonds, and alkynes will have the triple bonds. Because carbon can form single, double, triple bond, the probability of forming more and more compounds will also increase. In the next video, I am going to explain hybridization in detail for different set of molecules, and also I will tell you how to determine hybridization for the given carbon using simple tricks. Now let's understand what is isomerism. Isomerism is a phenomena where a molecule with the same molecular formula will exhibit different physical or chemical properties, and this is due to the connectivity of the atoms. For example, butane molecule. Butane is a hydrocarbon with 4 carbons and 10 hydrogens in it. Therefore, its molecular formula is C4H10. How can we write the butane molecule? We can write carbon in a straight chain. It's forming straight chain due to the catenation property, and we know that carbon is tetravalent. That means it will form 4 bonds, and now let's satisfy that valency by writing the hydrogens. How many hydrogens we can write here? 10 hydrogens. And what do you call this molecule as? N-butane. As it is a straight chain of carbons, it's a normal butane molecule. Can we write the C4H10 in a different way? Yes, we can. How? We can do a branching. What do you mean by branching? We don't write the straight chain, we will do the branch chain like this. You see, the carbon is placed on the second carbon. Now we can write the hydrogens to satisfy the valency of the carbon. Still, the molecular formula is same. C4, 3 plus 3 plus 3 plus 1. So 10, C4H10. That is the molecule. And what is the name of this molecule? It's called as isobutane. Why iso? Because it's the isomer of the N-butane molecule. Now, will they have any different physical and chemical property? Yes, they do. For example, the isobutane boiling point will be less than that of the N-butane. That shows that these are two different molecules. So because of the isomerism, the carbon compounds like hydrocarbons, they can exhibit different structures for the same molecular formula. So this will increase the probability of forming more and more organic molecules. Let's take the last factor, that is bond stability. What do you mean by bond stability here? It shows the energy required to break the bonds between, say, carbon-carbon, carbon-hydrogen, carbon-nitrogen, etc. Carbon bond stability is due to its ability to form 4 strong covalent bonds, which allows it to form vast array of stable compounds by satisfying the octet rule. That means since the carbon is obeying the octet rule, that means it can have 8 electrons. You can see here 2, 4, 6, 8. 2, 4, 6, 8, right? So it can have 8 electrons. That means it is obeying the octet rule. Therefore, the bond is strong. Therefore, it's a stable molecules are formed here. Hence, carbon is considered as the king of organic chemistry. In the next lecture, we are going to learn the hybridization of carbon in detail. Thank you for watching this video.